and welcome to another video of our YouTube channel. Again, my name is Rhiannon and this is my dad.
Hi, my name's Nick, I'm Rhiannon's dad, and welcome to Science Sidekicks. For those of you who are new to the channel, this is where we do fun science experiments and mostly around electronics here in our kitchen at home. All right, so last week we were learning how to use a what? Arduino, okay? So we had an Arduino kit and we were learning about input and outputs and we were making some really basic circuits. And today we're going to carry on with basic circuits, but we're not using the Arduino this time. So what we've got here is a power supply, a voltmeter, a light bulb, and a switch. And we're going to make a really simple circuit that's going to make this light turn on. So the power supply is going to supply our voltage, which is the top number, and current, which is the second number. Okay? So if we turn this on and you close the switch, what do you think will happen to our light? It turns on. Right? You can see, but it's not very bright, is it? That's because if we look at our voltage reading here, and this is a voltmeter also, but we have a digital reading here as well, you can see that we're only supplying 1 volt. If we increase the amount of voltage by turning this button here, watch what happens to the light.
It gets brighter.
Gets brighter, okay? So the more voltage we have, the brighter it gets. So what we're up to now is 3 volts. So at 3 volts, you can see it's quite bright. And our voltmeter here is also reading 3 volts, okay? And you can see the amount of power we're using, which is measured in amps, is 0.22 amps. So now we have a basic concept that the higher the voltage, the brighter the light, right? And also the more power we're using or the more current we're drawing, which is measured in amps. Now what we're going to do is get rid of this power supply and we're going to build our own power supply. So you know what a battery is, right?
Yeah.
Put them in your toys. They generate what?
Power.
They generate power. They generate electricity. Okay? So we are going to generate electricity from a battery. But I don't have any batteries.
No.
So what are we going to do?
We are going to make our own batteries.
We're going to make our own batteries using this and this other stuff that you see over here. Now we're going to do it in 2 different ways. The first way is going to be a saltwater battery, and the second way is going to be using those lemons there. And we're going to have our voltmeter tell us how much voltage we're creating. And you've got a pen and paper here so we can write down some results, because we're going to be doing this a few times in a few different ways and see how it affects the amount of voltage that we are able to generate, okay? So we're going to fill each one of these with some salt water. So they open up, and you can see inside of them they have 2 pieces of metal, and they're different colors, right?
Yes.
Okay, one is copper, and the other is a metal called zinc. First thing we're going to do is weigh out some salt, because we want to see how the amount of salt changes the amount of power we're able to generate. Okay, so that's why we've got our weighing scales here, and we've got some salt. Now, we turn on the scales, and they're going to go to 0. And let's weigh out some salt. So pour a little bit in. Okay, so let that settle. 20 grams. Okay, so we're going to go with 20 grams of salt. You write this down?
Okay.
So in our first battery, we're going to have 20 grams of salt, and we're going to put it into 100 ml of water. Okay, now put the salt into the water. Okay, stir it up. So we've got it all mixed up. So we've got 20 grams of salt in 100 ml of water. Okay, so that's good. We've dissolved all of the salt in the water. So now we have 100 ml of salt water with 20 grams of salt in it. Now we'll pour that into our battery. Okay. All right. Now we'll put that into here. And we can now connect this to our circuit. So we put one to the positive here, and the other to the negative. And we'll connect this up to here, and we'll see what we get. Now, I'm not expecting a lot out of this one. We've got nothing, because we've only got one of these, and this is not a very powerful battery. So what we're going to do is we're going to mix up more solutions and fill up all of these, and we'll put these batteries together in series and see how that goes. Okay, so now we've filled all of these, and they've all got the same ratio of salt and water in them. Okay, and now we will connect them all up. And you can see we are connecting these in a series circuit, so it's one after the other. Okay, which means that each one is going to add to the next, so our voltage will be higher. So there is our bank of batteries, and they're all connected together in series. Okay, red to black, red to black. Okay, and then we will put, because I don't have any more red wires, this here, I've got this one red one here. So one side connects to the input here. Okay, now hopefully we're going to generate enough power to light the light. Let's see what voltage we get with this. You can see our voltage reading, it's gone up a little bit on our voltmeter here. Take a look. Okay, so the voltmeter's gone up a little bit, which means we are generating some power, but not enough to light this, because this is an incandescent light, which means it uses a little bit more power, right? And we can't generate quite enough from this. So we have, where's the LED? The LED uses a lot less power to light. So let's see if we can get the LED to light instead. Remember, there's an anode and a cathode, so the positive goes to, which one is the anode on the LED? Remember?
The big one.
The big one, the long leg is the positive. So we'll connect that to one side there, and we'll connect this to the other side. And there we go. Do you see our light is lighting up a little bit?
Yeah. I think we need to go a little bit closer, though.
You see that on the camera?
Yeah,
You see,
like
when I disconnect it?
Little red thingy.
Yeah, there's a little bit of red coming from that, you see?
On the top.
So we've got a little bit of power being generated from this battery. Now, we're going to try and make this battery more powerful. One way we can do that is by increasing the amount of salt that we have in this, okay? So what we're going to do now, guys, is we're going to add more salt to the solution. That will make more of an electrolyte, which will increase the amount of voltage that we can get out of this. Okay, so now we've doubled the amount of salt that we've got in there, right?
Yeah.
So before we had 10 grams per container, and now we've got 20 grams per container because we had doubled the amount. So let's see if it makes a difference now to our LED, if it's going to be any brighter. It should be, okay? Because now we've got a stronger electrolyte solution. We should get a stronger LED light. Let's see what happens. It's a little bit stronger than before.
Yeah, I can see more of it.
Yeah? So it's a little bit stronger than before. And if we connect it up to our voltmeter, we can see how many volts we're actually getting out of this now. So if we connect positive and the negative together, we're getting not even quite half a volt. Okay, we've got about 0.2 volts. It's not going to be enough to light this. This will not light with that, because this is an incandescent light. It requires more power than LED. So this is a good example as to why in your house, if you use LED lights, right? If you use LED light bulbs instead of incandescent light bulbs, you save
more power.
Save power, which saves the environment and also saves you money. So this is a good example here as to how we can get, with a small voltage, we can get something out of the LED light but we're not getting anything out of the incandescent light. Now, there is a way that we can make this even more powerful, which is adding hydrogen peroxide. Now, hydrogen peroxide is an oxidizing agent. It's used as an antiseptic. And what it will do is it will increase the rate of the reaction. It will provide more oxygen to the reaction, which will allow the transfer of the electrons from the anode to the cathode to go faster, which should make things brighter, okay? So let's add some hydrogen peroxide to each one of these. Okay, so we forgot to write down the results from the first one. The second one. So we doubled the amount of salt. Okay, so we had 20 grams per. Okay, and we got a voltage of about 0.2 volts. Okay, so now we've added the hydrogen peroxide to there. It should allow us to get a little bit more power out of this. So if we connect now the anode and the cathode together. Noticeably brighter now, right?
Yeah.
Much brighter than it was before. And if we connect it now to the voltmeter here, we can see how many volts we're actually getting by adding the hydrogen peroxide. Look at our volts now. We're getting almost 2 volts, okay? So before we had 0.2 volts, right? And now we've still got the same amount of salt, 20 grams of salt, but we added about 5 ml of hydrogen peroxide. And now we have 2 volts. Now, possibly might be enough to power this. Let's see. Still not enough. It's dropping down. Okay, so still not enough to power the incandescent light. But you could see, noticeably, we have a lot more power
than
before just by adding the hydrogen peroxide. So now let's explain some of the chemistry and physics behind what's going on here. So we have the anode and the cathode, okay, which are 2 dissimilar metals. Now, the copper wants to pull electrons from the zinc.
Yeah.
Okay, so the copper is trying to say, hey, electrons, come over here, come to me. Now, with the electrolyte solution, which is the liquid which we added salt to, that makes what's called an electrolyte, a solution which can conduct electricity. And the ions that are in the salt ions, are able to help the copper pull the electrons from the zinc to the copper. And when electrons move from one place to another, that's a flow of electricity. Okay? Now, when we added the hydrogen peroxide, it provided more oxygen to the chemical reaction that's going on there, which allows it to happen faster. And now, if you zoom in on this, you can see you got little bubbles forming around those.
Yeah.
Okay, so what's actually being created there now is hydrogen and oxygen gas. Okay, and the reaction's going faster because we added hydrogen peroxide, which contains additional hydrogen and oxygen. Okay, now we could collect the gas that's coming off the anode and the cathode, and we would be generating pure oxygen and pure hydrogen, which is an experiment that we'll do another time. Hydrogen gas is explosive, so you got to be careful with these things, and that's one of the reasons why batteries can produce hydrogen gases which can cause them to explode. We've managed to create a battery which can power an LED light out of nothing more than salt and water and a little bit of hydrogen peroxide. Now what we're going to do is do the same type of experiment but using lemons. Okay? So lemons have citric acid inside of them. Okay? That's what gives them their taste. That's what's in the juice. The juice is a citric acid. That's why they're called citrus fruits. Okay? Now, the citric acid is also an electrolyte, like the salt water.
One question. Can we use already squeezed lemons, like lemon juice in the fridge? Yes, it will work in the same way that you could squeeze the lemon juice and we could put lemon juice inside of here instead. That's going to take us a little bit of time to do that. And also as well, the lemon juice is probably going to end up going to waste. We're going to reuse these lemons afterwards to make lemon juice. All we're going to do is stick an anode and a cathode inside of each one of these. Okay, and we're going to connect them up in series. That's going to be done in the same way that we've done with the batteries.
And the acid inside of here is going to act as the electrolyte, and it's going to do the same thing. Okay? So let's get that set up. So here's our lemons with the anodes and cathodes inserted into them. And when we wire these up, they're in series. We have to make sure that the copper goes to the zinc, the copper goes to the zinc, copper goes to the zinc when we connect these up. So here's the crocodile clips. You want one as well? Mm-hmm. There you go. So you connect it up. So I'll do this one here.
I'll do these ones on this side.
Now, what do you think, Rhiannon? Do you think we're going to get more voltage or less? Just take a guess. What do you think? Do you think
for
lemons?
a guess, I think I would say more.
You think we're going to get more? Let's see. Oh, the needle hardly moved, so we've got a lot less coming out of this. Let's see if there's still enough to get some power to our LED. Very, very dim. Hardly saw anything, but when I first connected it, it did.
Oh, yeah.
There's a little bit. Can you see it?
You
got to get it just the right angle. There's a very small amount. Can you see that on the camera? Yeah. It's a very small amount of power, very small amount of voltage. So we got more power out of the saltwater batteries than we did out of the fruit. Although we do have only 4 lemons and we had 5 of the saltwater batteries. But even if we added 1 extra lemon here, it's not going to make a big difference. Okay? Yeah. But it just shows the concept that it works with lemons and with different chemicals, different electrolytes are going to give a different amount of power. So in the batteries that we buy from the store, they have something in them called lithium ions. Yeah, or they might be alkaline batteries. There's different types. Different types of batteries have different liquids inside of them or different electrolytes, and that affects the amount of power they can generate. Okay? So, what do you think of this experiment?
I think it was pretty good. Plus, we get some lemonade out of it.
Right. We're going to squeeze these lemons and make some lemonade.
So, thank you for watching, and don't forget to like and subscribe.
We'll see you next time.